In a bustling radio station, engineers are puzzled by the challenge of transmitting high-quality sound over long distances without distortion. AM, amplitude modulation, signals, which they've been using, are prone to noise interference. Jane, a young communication engineer, proposes a solution: frequency modulation, FM. She explains, instead of varying the amplitude of the carrier wave to encode information, let's vary its frequency. FM signals are less affected by noise because amplitude variations, caused by interference, don't alter the encoded message. Her team is intrigued. They decide to build a prototype transmitter to test her theory. Jane's team sets up a basic FM transmitter. She demonstrates the concept using a simple sinusoidal wave as the carrier. Here's how it works, Jane says, pointing to a graph. The frequency of this wave increases when the audio signal amplitude is high, and decreases when it's low. She uses a microphone to input her voice. The oscilloscope displays a fascinating pattern, a carrier wave whose frequency dynamically changes. What about decoding this? A colleague asks. Jane explains the role of the FM receiver's discriminator circuit. It converts these frequency variations back into the original sound. The team sets up an FM transmitter tower and tunes in with an FM radio receiver in a nearby town. They broadcast music over the FM band. Listeners are amazed at the crystal-clear quality. Unlike AM transmissions, FM is unaffected by static or electrical noise from nearby machinery. Jane explains, FM's resilience comes from its greater bandwidth and immunity to amplitude-based noise. The experiment proves successful, and the team prepares to propose FM for mainstream radio use. Months later, FM becomes the new standard for radio. Jane's innovation also sparks interest in other areas of communication. FM principles are adopted in television audio, mobile communication, and even modern data transmission systems. Jane reflects on their journey and explains to her students, frequency modulation not only improved radio broadcasting, but also laid the foundation for robust, noise-resistant communication systems worldwide. It's the art of letting frequencies speak louder than amplitudes. Her story inspires the next generation of engineers to innovate further in the field of communication.